Alright, question 6 of tutorial 3. For this question, I'm more interested in finding out how are we going to construct our differential equation from the information that the question gives us. How can we do it? Let us first understand what the variables in the question are. The first most important variable is time, t, which we take in terms of seconds. The next variable is s, which gives us the amount of chlorine in grams g in the tank at the time t. After that, we also need the volume of water in the tank. This is also a function in terms of time. We will measure it in liters L. So we have t and two variables which depend on t. S, the amount of chlorine in grams, and V, the volume of water in liters. Let us look at the information that the question gives us. How can we find a formula for V of t? Let us see what the question tells us. First of all, it tells us that the tank starts with 400 liters of water. This is the starting amount of water. Next, water is entering the tank at a rate of 4 liters per second. Therefore, once we hit time t, we had added a total of 4 times t liters of water to the container. Look at how the units make sense. 4 liters per second times time in seconds is going to give us an answer just in liters. So that is the next piece of our formula for Vt. We are adding 4 times t liters of water to the container. The next thing we know is that water leaves the tank at this rate, 10 liters per second. Therefore, at time t, we must take away from the tank 10 times t liters of water. Again, check that the units make sense as well. Liters per second, seconds. So the final quantity is in liters. That is the next bit. We are now subtracting 10 times t liters from the tank at time t. So our formula for Vt is going to be given by initial quantity plus what we add in minus what we take out. 400 plus 40 minus 10t gives us 400 minus 60 in liters. We also want to find out what the concentration of chlorine is at time t. In other words, if we think about units, we want to understand how many grams of chlorine are there in per unit volume of water, which is in liters. This is given by S of t divided by V of t. Again, observe that the units make sense in this situation as well. Grams for S, liters for T. This measures as a function the concentration of chlorine in the tank at time T. We have our formula for volume, so we plug it in. It gives us S of T divided by 400 minus 60. This is the. Moreover, the question tells us that water with chlorine doesn't enter the tank at all. We are not in any water with chlorine into the tank. So the rate at which we add chlorinated water to the tank is 0 grams of chlorine per unit time. Time here should be in seconds. 0 grams per seconds. However, we understand that chlorinated water does leave the tank at this rate of 10 liters per second. The water leaves at 10 liters per second. Therefore, we see the rate at which chlorine leaves the tank. Remember that chlorine is measured in grams, so the rate should be in grams per second. So looking at our form, we have the concentration of chlorine in the tank, which is constant throughout, because the mixture is constantly stirred, times the rate at which the water with chlorine leaves the tank. It is concentration given by this formula, the units in grams per liter, times rate at which chlorinated water leaves the tank. And you can check. We have this as the formula: 10 times S of T divided by 400 minus 60. And the units once again match up. Grams per liter, liters per second. What you should get is grams per second. Therefore, when we talk about the rate of change of chlorine in the tank, it is precisely in this grams per second. And the final rate is going to be at time T, the rate at which chlorine enters the tank in grams per second, minus the rate at which chlorine leaves the tank in grams per second. The rate at which it enters is 0. It's over here. The rate at which it leaves is over here. We plug that into our formula. So this is the differential equation that we have. dSdt equals minus 10 times S divided by 400 minus 60. And we can solve this using the method of integrating factors. It is also possible to use separation of variables to solve this, and you can try to do so. At the end of it, if you do your calculation correctly, you should get S, the amount of chlorine, in terms of this formula. Arbitrary constant C times 400 minus 60 to the power of 5 over 3. Then you will use in the question to solve for C. The question tells us at time equals to 0 what the corresponding value of S is. You can see what it is from the question. Solve for the value of C, and that will give the solution to question 6. So that is all we have for question 6.